Hi, it's Richard here from Intelligent Advisor IT Consulting again with another in our steps on our learning journey, learning about relationships. Here we're going to be talking about self-referential relationships. So I'm going to go ahead now and create a simple project to demonstrate the concept and also to demonstrate a very important idea that is often found when working with self-referential relationships. To flesh out the project, I'll create a single entity called the child. And let's tidy this entity up a bit and get it ready for the demonstration. The first thing I'm going to do is I'm going to change the attribute text to make it a little easier to read. There's nothing hidden behind this. It's just I want it to be a little more natural English. So this is going to be the child's name. I'll add a second attribute called the child's date of birth. Because if a child has the same date of birth as another child in the family, well, I consider that they're twins. I realize that's a very limited definition of what a twin is. I'll also make sure that just for the purposes of completion, I'll change the relationship text for the containment relationship to the children, which is what we'd use in English. And now I can go ahead and create my self-referential relationship. A self-referential relationship is exactly what it sounds like. It's a relationship that has both the source and the target being the same. So I'm creating a relationship called the child's twin, and it's between the child and the child. That's exactly what it is. Now that I have my relation set up, I can go ahead and start working on the rules to define when a child is a twin. To make our learning journey a little more interesting, we're going to walk through it, starting with something that looks right, but in fact is completely wrong. I'm going to open up Microsoft Word and create a simple rule that says, I consider a child to be a twin if they have the same date of birth. The child is a member of, you'll remember that function from another step in our learning journey, if the child's date of birth equals the child's date of birth. What could possibly go wrong with that? It all seems very clear. So I'm going to restart the debugger, just refresh and restart the debugger now, and I'll go ahead and create one child. Let's call this child Pauline. And let's give Pauline a date of birth, something like 2002, 1st of January, to keep it nice and simple. And already I can see there's a problem. The debugger says that Pauline is Pauline's twin. How can that possibly be? Let's create somebody else. Let's call the second child Paul. And let's give Paul the same date of birth. So now things are getting even weirder because Paul is Paul's twin as well as being Pauline's twin, and Pauline is Pauline's twin as well as being Paul's twin. Clearly there is something wrong with the way this rule is being interpreted. It's as if it is not capable or is not clear as to how to compare each of the entity instances. And this is actually precisely what's going wrong. We need to verify that in our rule we are being clear as to how this should happen. And to do this, we're going to use something called an alias. An alias, in spite of its name, just means a clarification as to how to address a rule that will compare entity instances. Now, the isMemberOf function is one of the functions that will accept an alias, and I've written in the other child as my alias. Once the other child has been established as an alias, I can use it on one side of my conditions. So I could say the child's date of birth equals the other child's date of birth, and I could also do something like the child's name is not equal to the other child's name. So the use of the word other makes it easier for me to read because I can understand that I'm comparing instances, but it's also essential for Oracle Intelligent Advisor. The syntax of isMemberOf and the use of an alias comes from the online documentation. You can see that both the long and the short form of this function allow me to use an alias. There are other functions that allow us to do it, and we'll see other functions in this family a little bit later on in another learning journey step. Now that I've clarified this, one final point. The use of the word other here, the other child, that's just my choice. If I want to put a different word to mean the same thing, I'm entirely able to do that. So let's say I wanted to say the alternative child, or I could use any word I could use to describe that it's not the same child. So I could go ahead and use the alternative child as long as I remember then to replace it everywhere that I use the word other. The other thing if you pardon the pun, is that when you're working with aliases, they have a scope. If you define it as I have done in the conclusion of this rule, you can use it anywhere in the conditions of this rule. I'm going to put it back to other because I think other was actually a better choice. So anywhere within these conditions, I can use the other child. But it's important to realize that I haven't created any entities, I haven't created any relationships. In fact, if I use the go to button here, it'll simply say, nope, that's not an attribute, and that's not a relationship, whether I be on the other child or the child. It's important to realize that you haven't created any attribute or relationship here. You've simply created an alias. As I mentioned previously, if I was to finish that paragraph and start writing another paragraph, the alias is lost. I would need to write another function that uses an alias to re-establish the alias. So aliases have scope, like most of things in Oracle Intelligent Advisor. Now I'm going to refresh the debugger, and let's go ahead and I'm going to create two children. This time around we'll call Pauline again, and we'll put in Pauline's date of birth, and we'll add Paul. Notice this time already that Pauline is not the twin of Pauline, but now when I add the date of birth, let's add first of all a different date of birth. You can see that Paul and Pauline are not twins. Let's change Paul's date of birth to match Pauline's, and we'll see that Pauline and Paul are now twins. Paul has a twin called Pauline, and Pauline has a twin called Paul. If I go ahead now and change the name of one of the children, because you'll recall that was actually part of my logic. In case I put Paul twice, Paul is not a twin of Paul because clearly, according to my rules, it's probably the same person. So I'll go ahead and change to Janet. And this time around, Janet is a twin of Paul and Paul is a twin of Janet. In this little exercise, you've learned three really important things. One is you can create self-referencing relationships. Two, they will often require an alias to make the rule really clear. And three, as a bonus, we've seen our isMemberOf function again in another interesting use case. See you soon for the next step in our learning journey.